Okay, on this worksheet, you have 4 different functions. Your job is to figure out, do these functions represent linear, exponential, quadratic functions, or something else? Okay. Now, you'll notice that there's room for first, second, third, fourth, and fifth differences. Once you figure out what the function is, stop. Don't keep going. As soon as you know what it is, stop. Okay. So do that, and then answer question 1. So I'll pause the video and give you guys some time to do that. So fill out all 4 charts, figure out what type of equation it is, and then answer question 1. What did you notice about the first graph? The first chart? Linear, common difference is -30. Good. The second one? Exponential. How come? And so this one is going up, right? So we should get an m value that's greater than 1. So if you divide it the wrong way, you will determine that it's exponential, so you're correct. But you do need to divide this term by the term above it, and then you get 1.3. So if you ended up with what was it, 0.76? If you ended up with 0.76, that's the wrong m value because you can see that we're increasing. But as long as it's 0.76, 0.76, 0.76, then you know it's exponential. But if you wanted to write the equation, you need to divide it the correct way. So the next one I get 1.3, and the next one I get 1.299. How come? Because this number probably has more decimals than are shown. So that is really just 3. And the other ones are going to be close to 3, but they're not going to be perfect because you don't have all the decimals. Okay, good. The third one, what'd you come up with? Quadratic because it has a common second difference. What is that second difference? -18. So if I were to write my recursive formula, I would write y sub 0 equals 425, and y sub n equals y sub n minus 1. What does this -18 tell me about the recursive formula? It's going to be minus 18n, and then there'll be another number off to the side probably. How do I figure out what that other number is? No, not necessarily 0. Not necessarily the 0 minute. But you just have to adapt it. If you take last year and you subtract 18n and it's a little bit bigger than it's supposed to be, then you'll just subtract some number to make it match. If you do y sub n minus 1 minus 18n and it comes out to be a little bit too small, then you're going to end up adding something to make it match. So that's really easy to do. If I were to write my explicit equation, I get y equals, and it's x squared. What does this second difference tell me about the coefficient on x squared? It's going to be half the second difference, so it's going to be -9x squared. And those are kind of important things that you want to remember. Okay, fourth one. What did you find out about the fourth one? It's neither. Did you figure out what type of polynomial it is? X to the fourth. So my first difference didn't work, my second and third differences didn't work, but that fourth difference matched. Now writing an equation for a fourth difference is something we're not even going to talk about. Okay, so number 1, how do you tell if a function is linear? Constant difference. How do you tell if it's exponential? Constant ratio. Quadratic. Constant second difference. And how do you know it's a polynomial bigger than quadratic? Third difference would mean x to the third. Fourth difference would mean x to the fourth. So the number of the difference matches the exponent on your x value. Okay, good. All right, number 2. What type of function are we looking at in number 2? Well, I actually have a couple choices. What could it be? It could be quadratic. It could be exponential. And to tell you the truth, it could be x to the third, because it might look like this. So just looking at the graph doesn't tell us very much. Can we figure out for sure what it is? We can in this case because I have the numbers. What if it was an unlabeled graph? Then you have no idea. What if it looks like a parabola and there are no labels? You can't guarantee it because it could actually be an x squared graph looks like this. An x to the fourth graph can also look like that. So just looking at the graph is never enough. So if I look down here, 0, 1, 1, 2, 2, 5, 3, 10, and 4, 17. Well, I know it's not exponential. What is the ratio from here to here? Times by 2. Does it continue to multiply by 2? No. Multiply by 2.5. Then it's multiplied by 2 again. And then it's not multiplied by 2, so it doesn't work. Okay? So it's certainly not linear, but let's look at the differences. Plus 1, plus 3, plus 5, plus 7. So my second difference is plus 2, plus 2, plus 2, which means it's quadratic. Good. What do I know about my recursive equation? It's going to have a plus 2n, and then plus or minus something else. What do I know about my explicit equation? It's going to be 1x to the second, because that number in front of the x squared is always half of the second difference. Okay? Number 3. Well, let's find the differences. Minus 6, minus 6, minus 6, well, that's all I can do, right? Oh, minus 6 again. So linear. Okay, number 4 is a little bit tricky. You could graph it, but again, graphs without the numbers aren't very reliable. Is there another way to tell what this is? CJ? You simplify, you get 4x plus 6x squared. So it's a quadratic because the biggest exponent determines what type of graph it is. So if I had x to the fourth minus 7x squared plus 10x to the sixth, what type of graph is it? Which one of those determines the shape? The sixth, the biggest one. So I can ignore this 4x, and my largest exponent is a 2, which means that my graph is quadratic. Okay? I want to give you just a few hints for your homework tonight. Turn the page over. Look at number 7. What do we know about number 7? Nothing. We can't tell without the numbers. It looks quadratic, but you can create an x to the fourth that looks like a quadratic. So without the numbers, we don't know. Look at numbers 10 and 13. You notice anything funny about 10 and 13? It skips x's. So number 10 looks linear. Is it linear? No. So you need to think of another way to test to see if it's exponential or if it's quadratic. Same thing with number 13. We're skipping values. And when you skip values, it makes it a little bit more difficult. But there is enough information to tell you whether it's linear, exponential, or quadratic. Okay? This one is due tomorrow. Good luck.